Hi everyone, in this tutorial we're going to learn about integration by substitution. So before we get into some problems, I want to go over the goal and the purpose of integrating with substitution in general. So whenever you have an integral, something like this, usually you'll have one, two terms, maybe more. They could be multiplied, they could be divided. There's any number of different situations that you can find them in, okay? However, if you can't integrate them straight away, you want to try to use this substitution technique. So the purpose of using substitution is by using U substitution. So you need to pick one of these terms to use. Okay, and if you're not sure, then try them both, because one of them may be a better choice, but both of them could work. You just never know. So the first thing that you would do is you're going to write U, okay, equals. And now you're going to pick one of the terms to choose. So let's say we choose the first term A. Okay, the next thing that you want to do is derive U. So we need to find du. Now let's say that the derivative of A happens to be B. Okay, well that's what you want to happen. If you do your setup correctly, most of these terms, maybe with the exception of a coefficient or a constant, will completely be taken up by this substitution of u and this substitution of du, where you can replace A with u and B with du. Okay, that's the goal. So let me walk you through a very simple example of where this works. So this is the main idea, okay? All right, so this is the simplest version of an example that I can think of. Now granted, you could simply multiply this x by the x squared and get x cubed, but for the sake of showing you this process, we're going to assume that these two terms can't really be multiplied, okay? And that's what you'll find in substitution. So what we want to do first is test them. So maybe you're not sure, well, do I use the x or do I use the x squared? Well, we're going to test both of them so you can see. So let's say we start with the first term. We're going to have u be x, okay? Now the next part of this is to derive u. And the derivative of x is just 1 dx. Now, you want to see if you can actually solve for this dx. And once you get enough practice, not solving for this dx won't be necessary because you'll already kind of see where the puzzle is leading you. Okay, so if I were to solve for dx, I would divide both sides by the 1 that's right here. Okay, so we divide both sides by 1, it remains the same. So du is just dx. All right, so what you're going to do is we're going to check this one. So let's try all the substitution that we have. Now, the first thing that I did is I replaced this x with a u. That's right here. Okay, so we're going to write u instead of x. Now, the x squared, you cannot make that a u squared. It has to be the identical term that you're looking for. Okay, you can't do that. So since we have no substitution for it, we're going to leave it as x squared. Okay, now dx, that was replaced here by du. So instead of writing dx, I'm going to write du. Now, if this was the correct substitution, okay, this somehow, right here, would have canceled out, okay, or it would have been replaced by something else. Since that's not happening, and I have mixed variables, I've got u's and x's in here, this substitution of u being x will not work. So we have to try the other way. We're going to have to try to make x squared our u instead. So let's try that. So let's have u be x squared. Okay, and our derivative of x squared would be 2x dx. And again, we want to try to get dx by itself, at least here in the beginning. Okay, so if I were to get dx by itself, it's being multiplied by 2x, so we're going to divide both sides by 2x. That's going to give me 1 over 2x du equals dx. So let's see if we can get the substitution in here. Okay, now the first term right here, I didn't have anything to substitute it with, so I'm just going to rewrite it, x. Okay, now the x squared part is now u. Okay, and dx is now 1 over 2x du. And that came from here. So if we look at this really carefully, we can actually see that this works in our favor. This x right here and this x actually cancel each other out, right? So we're going to cross them off, okay, and we're going to rewrite our integral. So we now have the integral, and I'm going to rewrite this so that the 1/2 right here is written first. So 1/2 u du. Now, we want to observe this is everything in terms of one variable that is u. And the answer to that is yes. I have a u here, I have a du, okay, and this guy, the 1/2, can simply be taken out of the integral. Okay, now if that's the case, you can go straight ahead and integrate. So we're going to go through that process. So I'm going to have 1/2, and please forgive my pen, it's not working quite well. So u du, and then we integrate. So we're going to add the 1/2, and then we are going to multiply that by the integral of u. Now that's to the first power, which means we add 1 to it, and then divide by that sum. So that's 1 and 1 is 2. Now you can rewrite that as just 1/2 u to the second power. That's the same thing as u squared over 2. Same thing. And then at the end, what we need is a plus c. And this is what you're going to be doing for every single indefinite integral, okay? And the last thing that we need to do is simplify and resubstitute. 1/2 times 1/2 is 1/4. My u originally was the x squared, so I'm going to replace that with x squared, and then plus c. And that is the purpose and goal of using substitution with integration.